Muy buen día a todos. Vamos a arrancar con el segundo y último día del tercer congreso del Instituto de Materiales Avanzados para la Manufactura Sostenible. Y pues bueno, para mí es un gusto poder darles la bienvenida en este momento. Gracias a los que estuvieron también el día de ayer y ahora nos vuelven a acompañar. En esta ocasión, bueno, quisiera expresarles mi emoción en tener este espacio de aprendizaje, en que la agenda el día de ayer está un poquito más enfocada a lo que era gobierno, los proyectos interdisciplinarios, y pues cerramos también con la decanatura, pero el día de hoy está enfocado a los proyectos de investigación que estamos haciendo con nuestros pares académicos en universidades en el extranjero, en universidades que el TEC de Monterrey considera aspiracionales. Entonces, pues hoy las conferencias, los paneles, las presentaciones con expertos van a seguir brindándonos nuevas ideas, perspectivas frescas de estos proyectos, de la colaboración que podemos hacer con nuestros pares y pues bueno, agradecemos mucho la presencia de todos aquí. To start this segment of presentations, I would like to give the welcome to two of our inviters to this conference. And we are going to start with Dr. Samer Adeeb. He's president of the engineer faculty at the Department of the Civil Engineer and Environmental in University of Alberta. And he's going to present to us the conference, The Future of Engineering in Academia, Technology, Innovation, and Humanity, with emphasis on construction engineer. So please, let's give a welcome to Dr. Samer Adeeb.
Thank you, Dr. Rita Fuentes. Let me just check. Yes. So first I want to say that when Dr. Fuentes started speaking in Spanish, I thought, oh my God, am I going to have to give my presentation in Spanish? But then she changed to English, so yes. Then I relaxed a bit. So I'm very, very excited to be here. I spent a few days in Mexico City, went to TEC de Monterrey, met a few of the undergrad students, saw the presentations yesterday, and then realized that really the histories and the paths of our two institutions are very similar. Very, very excited to see what's happening at TEC de Monterrey, and I really want to take the next 40 minutes to talk about both our institutions, what we're doing at our institution, and how it really our histories are very similar, and hopefully our futures are very similar, where we're going to have a lot of collaboration together as well. So I really going to give just some high-level thoughts about the future of engineering in academia, particularly talking about technology, innovation, and humanity. And I'm going to use some examples from our department in construction engineering to illustrate the ideas that we're talking about. Some acknowledgements, some of the images were generated using ChatGPT, and these are some of the books that I used some of the ideas in the presentation. So first, where is the University of Alberta? I don't know if anyone has ever been up that far north. We're about 7 hours away from TEC de Monterrey in a very nice city. This is the picture of the city in the summer. I know Dr. Cruz as well has some very nice pictures of our city. This, of course, we have a very, very nice summers, but our winters, unfortunately, I don't know if anyone has ever seen a scene like this. I don't think it ever happens here, but our winters are very harsh, but it's a very, still very nice place that we enjoy. We also have amazing nature in our area at the University of in Alberta. This is a picture of Lake Louise, one of the very well visited and preserved sites in nature sites. All right, so first I'm going to talk a little bit about me, then I'll talk about the history of the civil at the University of Alberta, and I want to show you how it aligns with the history of TEC de Monterrey. Then I'm going to talk about innovation, humanity, and then some final thoughts. Just for the sake of time, there are some slides. I have lots of slides, so I might just skip through some of the slides. So a little bit about me. I joined the university, I came to Canada from Egypt originally in 2001. I joined the University of Alberta in 2007. I worked in pipeline company. I had a very meandering path. I did biomedical engineering, and then I worked in pipeline company. The one point that I wanna really highlight is that in 2012, while I'm a professor, I went back and did a master's in mathematics, and that had a huge influence on my career because it taught me how to think about the fundamental things of everything that we're doing. I've been doing administration for many years. I was interim chair for the department, associate chair, associate dean, chair, and now I'm chair for the next 5 years. Very, very big department. I do a lot of numerical modeling for pipeline applications and for biomedical engineering applications. One last thing is that one of my hobbies, my favorite hobby is playing squash, and this is before I was doing administration. I actually won an award, and that will come later in my presentation. So let's talk about the history of civil at the University of Alberta. The history of the department and the history of the formation of the faculty of engineering are one and the same. Our department in the civil and environmental engineering was the first, when the University of Alberta started in 1908, they hired 4 people. And one of them was actually was hired for the Department of Civil Engineering. And that was William Moyer Edwards. And really, what I like about what I've noticed in the culture of in the Mexican culture in my visit now is that the Mexican culture really like to honor their predecessors, and this is really what we'd like to do as well. We also like to honor our predecessors. So William Moyer Edwards is really one of the first 4 that actually joined the University of Alberta. He came from McGill. He was an athlete. He taught the students. He taught the students mathematics and design. He also taught the students how to be athletes. He taught them rugby and he taught them boxing. And he also maintained professional practice. And this is something that will come across throughout my presentation. He maintained professional practice. He actually redesigned a water intake that eliminated the cause of a pandemic in Edmonton. But with an ironic twist of fate, he actually passed away at a flu pandemic in 1918. But the story goes is that he was actually one of the people that was the director of helping those who are actually having the pandemic. And just because of how he really cared about the students and he really cared about the people, he actually caught the flu and unfortunately passed away. And so in honor of him, and similar to what I see here throughout in Mexico, is that we have a very nice award to recognize people who actually serve their community. Similarly, we have another person that I really would like to honor today is Ibrahim F. Morrison. He joined us in 1912, one of the early professors in civil engineering at the University of Alberta, and he was the father of soil mechanics. He was the first person to teach soil mechanics, and he maintained his professional practice as well. Every project in Edmonton, he actually was one of the main consultants for that project. And in honor of, he also really cared about the students. What it says, the story goes, is that whenever people during his derivations were not paying attention, he would stop and talk to them about the application so that he can attract their attention. So, in honor of him, we have one of the biggest structures lab in North America in our department, and that lab is actually named after him. We've been doing a lot of innovation in construction since our inception. During the World War, our university, or our department, was actually looking at building or doing research on ice, trying to build floating bridges for the airplanes to land. The first MSc in civil engineering happened around 1922, and again, it's an investigation to determine the concrete making properties of certain aggregates in local use at Edmonton, Alberta. The reason I'm talking to you about all this is just to illustrate how connected we are to our industries around in Alberta. And also, the reason I want to talk about all this is because to properly envision where we are going, we really need to see our present in the eyes of our past. And so this is me with one of the really early chairs, Dr. Robert Morgenstern, and what he said that we've always been, our history is that we're always been at the cutting edge of professional practice, focused on innovation, and we've always been student and society focused. Now, when I look at Tech de Monterrey, I see the same thing. This is the strategic plan for 2025. You're talking about innovation and human flourishing. And so, really, our histories, I believe, are very similar. So first, now we keep using the word innovation. I really want to talk to you, what is innovation? So first, if you look on the University of Alberta and you type in the search button innovation, and you see that, oh my God, it appears in engineering 922 times. In arts, it appears 500 times. In medicine, it appears 1,400 times. When you're on the Tech de Monterrey and you type innovation, you see, there was no count, but you see product innovation, educational innovation, everything is about innovation. Now I want to take, there's a countdown here, but we can use some silence for 15 seconds or so. Now I want you to think, as I mentioned, really, it's very important for us to try to define what is it that we're trying to do. So I want you to think for 15 seconds, what is innovation for you? So if you try to define innovation, if you just even go to Google and say, or define any, so there's so many different definitions of innovation. And just, there's one definition that I heard recently and we've adopted, and that is innovation is progress that cannot be measured using incremental steps. Now, of course, you can come up with different definitions, but this is really the definition that we like to use in all, whenever we use or think about, whenever we use the term innovation. Now, why, I'm going to just give you a very simple example of what innovation is. If I don't know who was born, who's similar to my age, used those cell phones. Anyone use those cell phones? Now, for many, many years, cell phones always looked like this. Any progress would maybe add a button, maybe make it a little bit smaller, a little bit bigger, and then overnight, cell phones started looking like this. There's a huge leap, a huge step. You cannot measure it in any incremental step. So I'm going to just skip a little bit about my innovation in education. I'm going to talk about some of what things that I've done that I consider to be innovative. Early on in my career, we were given this problem, trying to figure out how to quantify whatever is happening in scoliotic patients inside using the surface of the patient. And at the time, they were looking at putting markers to try and understand what's going on. And the problem is when you look at those markers and you've got all this data, and if you remove this data and you look at those markers, these really obscure what's actually happening inside. And so because of my background or because of what I've done in mathematics, I've seen some definition of symmetry, and using that definition that I knew from mathematics, we came up with some sort of innovative way to actually assess this condition using surface topography and, using symmetry. And now we have a big startup that focuses on surface topography for scoliosis assessment. The point that I'm trying to say here is that the reason this is successful is because we brought a discipline that was really far from the the scoliosis. We could only solve the problem in scoliosis when we were able to use or grab some ideas from a completely different discipline. Similarly, I don't know if we, similarly, do we have 2 minutes? Okay. We'll keep this playing. So, as I mentioned, I'm very passionate about the sport of squash. This is perhaps, anyone here play squash? No? So these are the top players in the world. And when I was, as a scientist and an avid squash player, I really wanted to know, I mean, I thought that maybe I could play like these guys. So I thought, as a scientist, I just really want to study how these people are moving and who's winning and who's losing. This is really one of the most exciting squash rallies that you will ever watch. So the point is, as a scientist, I really wanted to understand, I mean, what is happening? Why are these guys so good when I jump on the court? I just don't know how to play. So we got some undergrad students. If you can click play, please. We got some undergrad students, and we got downloaded some videos, and we had these undergrad students just, if you see the lines, we actually had them look at the track their feet and try to understand, okay, what is happening really? What is who's winning and who's losing? Where are they on court? How fast are they? And then maybe later, we had a computer scientist, a professor from a professor in civil engineering with a computer science background, who actually, instead of using markers, actually automatically tracked. And then we were able to quantify the difference between the winners and the losers in the sport. It didn't help me, but we were able at least to publish a few papers on it. And so I'm talking about, again, what we were able to do is just get a completely different field, apply it to field squash. They'd never really heard of this, and we were able to produce, for me, some innovative research. And so when we talk, so the question is, okay, how do we actually reach that innovation? So when we talk about, we were always saying we want to innovate. So how do we actually achieve this innovation? So I'm going to give you some ideas, of course, some general ideas about innovation, how you achieve innovation. One of the very nice articles that I once read in University Affairs is the idea of that there are two types of researchers. There are the divers and there are the surfers. The divers are the ones who really dive very deep, really try to understand every nook, every cranny and nook within that area, and spend all their lives just in that corner, trying to see it a little bit clearer and clearer and clearer. We need the divers. We need the divers to actually make us understand the discipline-specific ideas. But we also have the surfers, and the surfers are the ones who surf around, just find a spot that they really like, they go in, they see it, they understand what's going on, they go up, and then they go to the next. We also need the surfers, because what happens, the innovation usually happens at the border between different disciplines. Similar ideas appear in a very nice book that I really recommend that you take a look at it. And again, it compares those discipline-specific individuals, like a very deep frog versus a bird that looks at the whole area. And we actually need both. I just want to use a quote. In the past, information scarcity rewarded knowledge acquisition, and now with information abundance requires pattern recognition. Pattern recognition comes when you look at different disciplines and you connect different disciplines. So when it comes to our department, we have 70 professors, 80 subdisciplines. We talk, 8 subdisciplines: construction, structures, geotechnical, environmental, water, resources, transportation, mining, and petroleum. Over 500 grad students, over 1,000 undergrad students. And what we are trying to do, which unfortunately in the past, or in academia was really preferred the siloed approach. We've got the structures engineering professors on their own, the construction engineering professors on their own, but now we recognize that we have that wealth of, or breadth, and we're really, it's all for us now is about building these connections between these very strong researchers that decided at some point to build a wall between themselves and not to talk to each other. So I'm going to talk about innovation in construction engineering using some examples. We're very fortunate, as I mentioned, we're very highly connected to the industry, so we have a large amount of endowments that we use to do these research, to the research that I'm going to use. We have a nursery school, one of the most successful builders at in Edmonton or in Alberta, donated a large amount of money that is used for some of this research. And the nice thing is that the research that we do is actually right away used in those industries. We have a big endowment called Whole School of Construction. We also have a conglomerate of construction industries under the Construction Innovation Center, and we also have the nursery school, and we also have the Masonry Center with a huge amount of endowment. I think Dr. Cruz will be talking about it a bit later. These are some of the people that I'm going to use show some of their research. As an example, we have experts in every material for structural engineering. We've got wood, we've got steel, we've got concrete, we've got masonry. But really the innovation now that we're doing in structural engineering is not about a particular material, but it's more about connecting these different materials. So now we're looking about how to build with different materials and how to work with the current codes, because we know how codes really try to standardize everything, but how do we work around those codes so we can actually innovate in building using this intersection of these materials. We recently built a very, as I mentioned, as you've seen earlier, the weather in Alberta really varies between very nice and to very cold, and because of this, we really need to understand how the materials behave with a very large gradient of temperature. And so we built an amazing, and that is actually thanks to the Masonry Center, the endowment that we have in the Masonry Center that provided the funding for us to be able to build a very nice high environmental chamber where we can have temperatures on both sides at a very high gradient, and we can do some structural testing for different materials under different environmental conditions. As I mentioned, the nursery school, which is really based on a large endowment given to us by one of the builders, they're very, very interested, and they're actually starting to use robotics for construction. So what they do, which is started really at research at the University of Alberta, is they build houses. Our houses are made out of wood, not out of concrete. We had a big discussion last night about which one is better. Who prefers concrete? Of course, everyone here prefers concrete. But right now, everything is manufactured using wood. So what we do is that they build actually the house off-site using robotics, and then they transfer the walls and everything. We have a professor from structural engineering working with professors from building engineering on solar PV integrated smart buildings. This particular professor, and just again to highlight the point that I'm trying to make, he has a degree, in addition to being a structural engineer, he actually has a degree in electrical engineering, because then he can link the knowledge needed to talk about PV, solar energy and buildings and what we need for buildings. Again, another example of the innovative things that we're doing in structural engineering is automatic drawing recognition, we have a professor who has a background, again, in structural engineering and a background and a degree in computer science. Now he's doing automatic drawing recognition, and also trying to use large language models such as ChatGPT for design, and we're using it for different things. Some of this design, interpretations of the code, and also we're trying to use it for actually teaching students. But of course you have to train them well, because if you don't train these large language models, then you get then you don't get what you're looking for. Similarly, we do a lot of infrastructure condition assessment using Internet of Things. If you play that video, so what you're going to see is that we're doing, yes, if you can play both. Again, this is professors from different fields working together. Thank you. What you'll see is that this is a car with a cell phone, and as the car goes on top of a bridge, the signal changes. And so the idea is, in the future, we can actually give an app to the individuals, and then we are just really doing a structural health monitoring, checking the vibrations of the bridge without installing anything, but rather just using the average computers, and then we're collecting the data and then looking at the signals and trying to see how the signals change as the condition of the bridge deteriorates. And similarly here, they're building an app that automatically identifies, you put a camera on your vehicle and it automatically identifies the areas that really require intervention based on the cracks seen in the pavement. All right, so we talked about technology. Now I'm gonna jump into humanity and talk about what is humanity for us and how important it is in an academic setting. So I'm going to give you three, so I want to talk about the purpose of a university. I'm going to use I'm going to draw from three different sources to talk about humanity and from three different perspectives. First, what is our purpose? Now, the traditional purpose for an engineering institution, academic institutions, particularly whether it's engineering or any institution, is to create, collate, curate, disseminate knowledge. And this is really what we do. We go to the lab, we test something, and we publish a paper, or we find a book, and we put it in our library. We create that, we collect that knowledge, curate it, put it in a library, and then tell the world about that knowledge. Now, another purpose that I've found from this very nice book that was written by Harvard Dean is that the general education, so what's the purpose? The general education means the whole development of an individual, apart from the occupational training. Very important, apart from their occupational training. It includes the civilizing of their life purposes, the refining of their emotional reactions, and the maturing of their understanding of the nature of things. Now, the third one, what is our purpose? This is, I got this from an article that discussed innovation as I was searching what is innovation. So the purpose of what we do is to shrink the economic divide between rural and urban communities, the access divide between those with means and those without, and the skills divide between what our economy needs to grow and what our graduates are prepared to offer. And so when I look at Tec de Monterrey, it's actually all these three things are, when you think about the history of Tec de Monterrey, that's one of the reasons why Tec de Monterrey was actually, was founded, creating an institution that could provide highly skilled personnel for booming Monterrey corporations of the 1940s. So really thinking about how can I economy and the society needs those skills. So how do I provide those skills to match our what the society needs? So really, our purpose in humanity, and I always want to remember those things. There's the knowledge, there's the individual. We really have to care about the individual that we're training and the society. Ultimately, that individual is going out in the society. So how do we prepare that individual so that when they're out in the society, they're actually advancing the society? And so we are part of the research that we're doing. I just want to point out that particularly in construction engineering, I just want to use that as an example, is it's not simply, the research that we're doing is not simply about productivity and just simply giving more profit to the industries, but also we really care about the individuals that are actually working. So, for example, in this research, we're using wearable sensors and advanced technology to improve labor productivity and well-being. Of course, productivity is important, but productivity and well-being, they have to go hand in hand. And so what they do is that they really try and understand the cognitive demand and how the cognitive demand on the worker affects their performance and their well-being. And similarly, there are certain construction sites that we want to do some inspection, and so right now we're using robotics and VR together so that we are able to do some inspection without actually having to go in the field. The other research, if you can play that video, please. The other research that we're doing is ergonomic risk analysis using computer vision. Similar to the work that I showed you in squash, we're actually now applying it also to the construction site. The last one. This is the last one. I mean, it's fun to see people, to see it moving, right? And so they are actually using this computer vision and to be able to track, and then some measures to identify those who are doing anything that is kind of at risk or that can cause them at risk, some ergonomic risk. So that really brings me, I just want to bring all this together, so that brings me to the end of my presentation. Really, the purpose of using all this, really what we think that our department, or the vision for our department, is to be leading innovation for societal advancement. And after being here and seeing what Tech de Monterrey is doing, and I'm very happy to see that we really are kind of thinking very similarly. When I look at Tech de Monterrey and I read about the culture, talking about innovation, collaboration, and inclusion. So it's really very heartwarming to see that we as humans living so many, hundreds of, 7 hours apart, and completely different weather, different food. I love the food here, but ultimately we really want to do the same thing. So it's very, very heartwarming. Just one last, I do have 8 minutes, so I want to talk about this. Technology, is technology the panacea? Should we just simply go after technology? Whenever we see a new technology, we just simply apply it? So one of the, I'm going to give you a story. I do have time. I want to give you a story. We had a new, I used to, early years, I used to manage this Abacus software, finance maintenance software. The software cost $20,000. And for me to be able to afford to buy this software, I had to line up 20 professors and get from each one of them their account number and a signature so I can purchase that software. I used to do this in the old times. I used to get a piece of paper, write their names, and walk, get them to sign, and get them to put the account number. It took me, I don't know, a day, 2 days, and it was lengthy, and I had to talk to the professors, and they don't want to give me the account number. Finally, they put it and they sign, and it's fine. But the university implemented a new technologically advanced system where you actually do this by email. Now, imagine, how long do you think it took me to get 20 professors to reply to their emails in series? more than 3 months. And so really when we start to think about implementing technology, we really have to think hard about this, the productivity paradox or the solo paradox. You can see the computer age everywhere, but in the productivity statistics. So you really have to think about it whenever we're implementing any new technology, how to train the people that are using the technology. Is it actually helping, or are we actually we should not be doing technology for the sake of technology. Technology is here to serve us, and it's not us to serve the technology. So, putting it all together, just want to finally say that those individuals that I honor today were generalists in a specialized field. It seems that at some point, academic institutions decided that we should have hyper-specializations. But I think right now we're moving back to also having these generalists, and I believe that we should have both, because with innovation, we need the generalists that can see the whole, and we need the specialized personnel that really increase the knowledge in a particular, very specific field. And that's the end of my presentation. Thank you very much.
We thank so much, Dr. Samer. And is there any question for him?
Oh, I'm looking at Gabriel.
You can make the questions in Spanish. We can translate it.
Oh.
Yes?
Oh. So don't have they increased the number. They increased the minutes.
Okay. No. Sorry, you spoke about the idea of a common future between Tech of Monterrey and University of Alberta. How do you think this common future could be? It's particularly because you have the position of as a dean or chair of the department.
So I talked with we have an associate dean here of the whole college, so he's a very powerful man, and you should talk to him about it later. But really the way I see it is that we have wealth of problems, and we would like to have a bridge between us and you, attracting students, bringing students, because I know the students at Tech de Monterrey are able to spend a term or are encouraged to spend a term outside Tech de Monterrey. So I'd like to make that very easy for them, to select from projects, and so we can actually make that as easy as possible. So we can attract the students, and I also would like to bring our students here if possible, just to see, so to me, this is the first step, is mobility of students. Because when the students come and then see that, okay, what I know, actually I can apply it in Canada, and the same way. So that's the first step. And the other thing is that we really want to think about how can we learn from each other? You're building houses with concrete, we're building houses with wood. How can we learn from each other? How can I bring your knowledge into Canada, and how can I bring our knowledge here? Or
Samir, a very inspiring talk. Could you give us your experience on how to manage the human nature of making this possible? And let me elaborate a little bit more. In the Mexican culture, at the scientific level, it's really hard, and I think my colleagues can recognize, to work together because some historical reasons, whatever the reason is, it's really hard to come up with good team effort in this country. You see at the Olympics, for instance, Mexico excels in individual competition. As a team, we're almost nothing. The same thing happens at the scientific level. What is your experience in Canada in the culture that you mentioned, and you point out that our institution highlights that as a part of the 2030 thinking. And what is your experience in Canada, coming you from a country, respectfully speaking, similarly to us with many issues and difficulties? Yeah. And what is your experience and how to bring people together to do all the things that you're doing? Could you elaborate on that, please?
Yes, yeah, that's a very, very good point. And I want to point out that humans are the same everywhere. So we have the same problem in Canada. We have 8 disciplines, and if I want to hire someone in construction engineering, structural engineering is going to raise their hand and say, what about me? What's in it for me? So we have that culture. To change the culture, there are 2 very important things: the narrative and the reward system. So to change the culture, you really have to be intentional about these 2 things. So every time I hear, what about me, we try to change the narrative from a zero-sum game or competition to what I call a problem-solving approach. How do we work together to solve this particular problem? Because when we solve this particular problem together, we're all going to win. As an example, well, I can't think of an example now, but it's all about intentional in the leadership approach. Very important about the leadership, because the leadership could change. It could decide to get the individuals to compete with each other, or could decide with the right narrative and with the right reward system to get everyone to work together. What we're doing is that every time we hear about a collaborative success, we put it in the news. We talk about, okay, look, here's what's happening. The professor so-and-so is working with professor so-and-so, and they're producing this amazing work. And then as people read about these success stories, it permeates and percolates, and people start thinking about it. What happens is sometimes you have a contradiction. If your reward system says you'll get merit if you work alone, and then you start saying, you give a story about collaboration, I'm not going to listen to that story because I'm interested in that reward system. So very important to think about the reward system that you have. Is it actually leading to collaboration, or is it counteracting? And so our reward system is still rewarding individualism, but we're slowly, because big ships, very impossible move to, very slowly trying to change that culture, talk about collaboration. Whenever we hear it, we're like, no, it's fine that those 2 people appear on the same paper. It doesn't mean that you have to give them half the merit. So it takes time, but it has to be very intentional from the top. Does that make sense?
Is there any other question? Comment? Yeah.
Hola, ¿qué tal? Eleazar, o sea, en español, por favor, para que me apoyen a traducir.
Oh, okay. So if it's a difficult question, I'll pretend that I don't understand it.
Hola, ¿me escuchas? ¿Qué tal? Mi nombre es Eleazar.
I can't hear anything. Maybe you could,
Yeah.
You can translate.
Hablas de la colaboración. Hablaste de tu historia en el cual un software tuvo un precio de $20,000. ¿Cómo equilibras la innovación con la colaboración, con ayudar a la comunidad y el recuperar la inversión de capital privado? Sí, sí.
¿Puedes repetir la pregunta?
Sí, ¿cómo equilibras que la innovación colabore con la comunidad y el que recuperes la inversión del proyecto.
A ver, nuevamente, por favor.
¿Cómo equilibras el que la innovación apoye a la comunidad y que recuperes la inversión de la investigación? Porque a veces, bueno, se vuelve costoso innovar.
If I understand your question is how do you balance? I think I understand what you're saying, and I think, let me tell you about what we do. We are fortunate that we have many industries that are interested in providing a lot of funding for us. Now, your question, so you get this funding, and if I understand your question, you get this funding and you have to provide for that particular project, but maybe how do you balance this with the needs of the environment or the people and everything? And it is not easy. And that's why when we hire at our institution, we're very careful that we hire those who can balance this. Because so as an example for my work, I work in the pipeline industry. So I get funding from a pipeline. I have to balance what is the need for the pipeline. I have to balance what is needed from the students. I can't be pushing the students just because I have a company that's sponsoring. And I have to make sure that what I'm doing is actually helpful to the environment. And so we, at all the time, have to balance this. And it's not very easy, but we like to think that we hire the right people. You hire the right people, you give them the right incentives, and you put the right amount of regulation. And I make that very, very, there's always that balance over regulation versus under regulation. You just have to find the right amount of regulation so that everybody can play together. I don't know if it's not easy. Like what you're asking is, yes, it is what we're struggling with all the time, is how to balance this.
Okay. Thank you.
Thank you, everyone, and thank you, Dr. Samer. We are lack of time, but
Thank you very much. Thank you. Yes, of course. Yes. Thank you.